All right, let's break tradition and right away have you write down Admiral Adama. Admiral Adama. A-D-A-M-A. All right, the subject of today's lecture is the nomenclature of acids. All right, so you sit down in an exam and you see the two compounds shown here facing you on an exam. How do you name them? Well, the first thing you have to do in order to name acids is recognize when you have an acid. There are two big clues that you have an acid. The first is a hard and fast rule. To name something as an acid, the first element in the compound must be hydrogen. That's your big clue that you have an acid. That's a rule, not going to be violated, right? So you're always going to ask yourself when naming compounds, is my first element hydrogen? If the answer to that question, is the first element hydrogen, is a yes, then that means you have an acid. There's another clue that's kind of annoying one when it comes to naming acids. If you look at these two examples of an acid, both of these have hydrogen as the first element, and both have the parentheses with an AQ after it. When you're being pinky fingers out, very formal, very rigid in your chemistry notation and your chemistry nomenclature rules, you always write acids in the aqueous phase. Matter of fact, some books will make a real big deal out of it and tell you name things a different way if they're not in the aqueous phase. Remember, our definition of acids defined acids as anything that loses a proton or loses a hydrogen ion in the aqueous environment. And therefore, some people will view the nomenclature rules very strictly, that you should only name something as an acid when it's in the aqueous environment. Therefore, your textbook, at least for one chapter, will be very rigid about whenever they write an acid, having it in the aqueous phase, which means you'll see these parentheses here with the letters AQ for it, meaning aqueous or dissolved in water. All right, so how do we name these? Let's take them one at a time. Well, let's not. All right, let's go back to our question map here, rather. Is our first element for each of these compounds here hydrogen? Yes. So we know we have an acid. The next thing we consider when it comes to naming acids is, do we have an oxoanion present? What in the world is an oxoanion? You probably can guess it from the name. An anion, remember, is a negatively charged ion. And what does oxo probably refer to? Oxygen. So an oxoanion is an anion that contains oxygen. All right. So let's start with looking at this compound over here. Is the first element hydrogen? Yes. Does it contain an oxoanion? No. So the rules for naming acids without an oxoanion So your rule for acids with no oxygens is to use the prefix hydro and the suffix ic acid. So here I have hydrogen and I have bromine. So what I'm going to do is I'm going to use the prefix hydro, the root bromo, but instead of putting IDE there, I'm going to put I'm going to put I'm going to put ic acid. So this would be hydrobromic acid. All right, so that's how you name acids that don't contain oxygen. What about ones that do? Is the first element hydrogen? Yes. Is an oxoanion present? Yes, right? Because we have hydrogen as our first element, so we have an acid. Then we see oxygen here. So our rule for naming acids with oxygen is as follows. Change ate to ic, change ite to us. So what you're really doing here is you're identifying the name of this polyatomic ion. Just as a quick refresher, because I'm sure that's all it is, that you've sat there working your index card since the last time we spoke, and you recognize that that is the bromate ion there, right? BrO3 negative, the bromate ion. According to our rule, to name this compound as an acid, I'm going to change ate to ic. So bromate is going to become bromic acid. Notice how similar the two names are. We have hydrobromic acid, we have bromic acid. The way you tell them apart is that prefix there. The most common mistake I see on exams is people want to overuse this hydro. Whenever you use the word hydro, you don't have oxygen present. Hydrobromic acid, bromic acid. All right, let's take a look at a lot more examples of each category. But before we do that, why don't you write down Starbuck? Write down Starbuck, S-T-A-R-B-U-C-K, Starbuck. All right, let's name acids without oxygen. Whenever we have acids without oxygen, we use the prefix hydro and the suffix ic acid. So we see hydrogen as our first element, so we have an acid. We don't have oxygen, so we use the prefix hydro, the root, and then the suffix ic acid. So that would be hydrochloric acid. Down here, we have hydrogen, we have fluoride, we don't have oxygen, so once again, we use the prefix hydro and the suffix ic acid. So hydrofluoric acid. Here's a twist, here's a new one. We have hydrogen combined with cyanide. Do we have oxygen? No, we don't have oxygen. So we're going to use that prefix hydro. We're going to drop that IDE suffix, right? That's what we were dropping from our fluoride up here and our chloride up here. So we drop the IED from cyanide to make it cyanic acid. So we have hydrocyanic acid, hydrofluoric acid, hydrochloric acid. Chemistry's easy, life is hard, yes? All right, oxygen-containing acids. For oxygen-containing acids, we're going to change ate to ic, ite to us. So let me put up dueling examples here. I have this compound right here, and I'm going to draw a related compound for you. I look at this compound. I have hydrogen as my first element, so I have an acid. I have oxygen, so that means I have an oxygen-containing acid. So I have to identify my polyatomic ion and change ate to ic and ite to us. ClO3, I'm sure you remember, is chlorate, and I change ate to ic. How I remember this is I asked my 5-year-old what happened to the cookie I left on the table, and he told me, I ate it. I ate it. I ate it, right? I ate it. So 8 becomes ick, no prefix. So 8 becomes ick. So I have chloric acid. Over here, I have hydrogen. I have oxygen. But this time, my polyatomic ion isn't chlorate, it's... The polyatomic ion is chlorite, right? Chlorite, ClO2 negative. And according to our rule, we're going to change ite to us. So this is going to become chlorus acid, because we change ite to us. So when you're naming an oxoanion, you pay attention to the polyatomic ion it's made from and change ate to ick, ite to us. For example, down here, I have hydrogen, so I have an acid. I have oxygen, so I know my rules are as follows. So I need to identify my polyatomic ion. Again, you've memorized that as carbonate. And we change ate to ick, so it's going to become carbonic acid. One last one to round this off. Once again, we've got hydrogen, we have oxygen, so we need to identify our polyatomic ion. We've memorized that as hypobromite. We change ite to us, so the acid would be hypobromous acid. Chemistry's easy, life is hard, yes? Alright, let's go the opposite direction, going name to formula. Going name to formula, the procedure is pretty straightforward. First of all, when you're going name to formula, it's really easy to tell when you have an acid because you see the word acid there. So let's take a look at an example. You're told you need to write the formula for sulfuric acid. Step 1, identify the anion. Well, we see the name sulfuric. Do we have the prefix hydro? No prefix hydro there. Since there's no prefix hydro there, we know that we have a Since there's no prefix hydro, we have an oxoanion. Then we see that it ends in ick. So that means it was replaced with 8. Right? 8 becomes ick, so ick becomes 8. So we have the sulfate ion as the base for building our acid. The next thing we're going to do is we're going to add 1 hydrogen ion for each negative charge. Sulfate has a 2 negative. So we have to add 1 hydrogen ion for each negative charge we have. So we have 2 negative charge, so we need to add 2 hydrogens, making our acid H2SO4. And then to make the pinky out crowd happy, we have to add that phase designation, AQ in parentheses. So that is sulfuric acid. And I would point out the reason I'm saying that so cynically is you'll discover your own textbook violates this AQ designation rule quite a bit after this chapter. But that's just something to point out there. Now try hydroiodic acid. All right, this time we see the prefix hydro. That means no oxygen. So all we have to do is identify the element. Right? We have IOD and ick. And if you can't figure out the element, remember ick replaced IDE, right? So IOD Diide was our element. It has a -1 charge, so we're going to add 1 hydrogen to it. So it makes the world's friendliest acid. Hi there. And remember our AQ. Chemistry's easy, life is hard. Why don't you write down boomer? Write down boomer. B-O-O-M-E-R. Write down boomer. All right, your turn. Before you listen any farther, please, I'm begging you, try these on your own, right? Please try these on your own. All right, did you try them on your own? Sure you did, because these look like fun. All right, so let's go through them. We have acids here because it's hydrogen. It contains oxygen. So now we just need to identify the oxoanion. IO2 negative is iodite. Ite becomes us, so iodous acid. Next we have hydrogen and fluorine, no oxygen there. So we use the prefix hydro and the suffix IC. So hydrofluoric acid. And I think I used that as my example on 2 slides ago, so I hope you got that one. Just like I hope you got this one. As you can guess, there's a limited number of acids I can ask you about. Here's a good one. We have nitrous acid. Do we see the prefix hydro? No. So we know we have an oxygen-containing acid. Us comes from ite. So we have the nitrite ion, which you've memorized as NO2 negative. You need to add 1 hydrogen for every negative charge. And then you need to make sure you add that AQ. So we have nitrous acid, hydrobromic. I did that on the first slide, so I hope you got it. All right, that's it. Chemistry's easy, life is hard.